Okay, good morning, folks. Just hello and welcome to our new method of going through some of the content that we're going to try to cover over the next couple of weeks. Okay, I'll be sending short videos like this through YouTube onto your class summary board. Hopefully you found that already. Going through exactly the exact content you need, some notes and keywords to look out for, and I'll go through the assignments in these videos very clearly as well, so you know exactly what to do. Okay, you'll need a highlighter, a pen. Let's make it a little start. All right. Okay, I'm on page 52, 53 of Bunnet. We're going to do 54, 55, 56 as well. All right, so as you can see, quite a bit to get through, so I'll jump straight in. Mass moving and slow processes. Okay, so first thing you can do is highlight that and add a little note above mass wasting is the same as mass movement. So if on any worksheets or any questions or anything you see mass wasting or mass movement, they're the same things. I've drawn a small little arrow up here as well, which I'll come back to in just a moment. Okay, first thing we need to know about mass wasting or mass movement is there are three factors which influence or affect all of our mass movement, and they're circled for you right down here. Okay, so on page 52, the angle of the slope, because all movement is downhill. Gravity, it's the force that pulls the material downhill. And water, that can either add weight to the material which is being moved or lubricate the surfaces to allow movement to happen. Okay, so you can circle those. These things together determine whether the regolith, now regolith is just the broken material or loose material involved. Okay, so it can be rock, soil, sand, clay, whatever. Okay, these three factors will decide whether the slope stays where it is or moves down the slope, whether or not it is stable. Alright, so again, all movement on slopes is determined by these three factors, or a combination. You will nearly always have a combination of these things happening. Alright, now move on to the next bit. Mass movement refers to the movement of regolith on slopes by creeping, flowing, sliding, slumping, or falling, affected by the three factors named above. So that's where my little arrow goes. Okay, up to here. So they're the different types. That's one of the questions on your assignment. We'll be asking you to name 4 types, and we got 5 here. All right, we'll go through those in more detail. Now, these are natural processes. If there's no humans, this would happen on different slopes. You'd have soil creeps, mud flows, landslides, rock falls, all of this kind of stuff. But however, next bit to highlight. However, the impact of human activities on slopes through deforestation, building of settlements, farming and mining have increased the instability of slopes in many parts of the world. Alright, so whilst this is a natural process, humans have had a huge impact through these different things. Deforestation, cutting down trees, building of homes, roads, bridges, everything. Farming, agriculture and mining. Alright, I know the video might get a bit blurry at times, but you should be able to see what we're doing. So to build on the human impacts, alright, from time to time, the growth of the first civilization, the effects of humans' impact on the Earth's surface have steadily increased. Pretty simple stuff. There's more people, bigger impact over time. Down the bottom here then, okay, vast areas of land have become derelict. Now derelict means to be left with no use. Nobody's using that land anymore. Through bad farming, which has destroyed the soil, that makes it looser and easier to collapse on itself, okay. Mining, which has cut up the surface into huge open pits and riddled the land with tunnels. Okay, so obviously underground mining loosens and weakens the ground, allowing these slides and falls and slumps to happen. Especially, okay, so that's what we're going to look at there. We're going to jump straight over into here onto page 53, okay, onto the types of movement. Now, beside the types of movement, I've written down speed and cause in each type. Okay, I think the camera's just refocusing. So for each of these, we're going to look at, is it fast or slow movement, and what causes each type to occur. First one, soil creep. All right, continuous but slow, so I put speed above that in brackets. Okay, soil creep is the slowest form of mass movement or mass wasting. Rain lubricates the soil particles and enables them to slide over each other. There's your cause. So remember, our 3 causes are always going to be angle of slope, gravity or water, usually 2 if not 3 combined. All right, obviously for mass movement to occur you need a slope, so you've already got that angle. The greater the slope, all right, the more or vertical the slope is, the faster the movement will be. So soil creep, continuous but slow. Rain is the main cause. Soil creep is a slow movement. Okay, I've put some pictures on the PowerPoint which I'll add to your attachment to show what it means, but it's a slow movement. A flow then, okay, we got some different ones like a mud flow and stuff here, okay. Flow is usually faster than a creep, so we're moving up through speed. All right. Also, a flow associates itself with something more liquid than a soil creep. All right. Heavy rain this time. So heavy rain falls, and again, you could argue the angle of the slope. So there's our speed and cause for flows. All right. On to page 54 very quickly. All right. These turn the surface. So the heavy rain turns the surface material into a semi-fluid state. So think of something like a honey or a treacle or a syrup or something like that, maple syrup. All right. It acts as a liquid and flows downslope, such as an earth flow. All right, now we got earth flow, and then we come all the way down here to mud flows. Pretty much the same thing, really. All right. Again, it is more rapid and less viscous than an earth flow. So mud flows, again, more rapid. So there's our speed. Okay, so we've gone soil creep, earth flow, mud flow now. All right. Torrential storms, more rain falls than soil can absorb. So that water, the soil becomes saturated very quickly and begins to flow downhill with the rainfall. All right. So now we got cause and speed. Notice how the level of rainfall is increasing. The soil creep was just with some water. Then we had heavy rainfall. Now we have torrential rainfall. All right. Something else to notice about mud flows. I want to highlight the word here: deserts, and also volcanoes. Okay. When we did our volcanoes, we talked about how those pyroclastic flows mixed with ice or melt water and lava and ash. Because ash is very fine and very light, when it mixes with water, it becomes like a big soup, and it moves very, very quickly down the mountain. So you can also get these mud flows on volcanoes or in deserts where the sand is very fine, like on a beach, and it can move very, very quickly. Okay, something else you need to know down here: solifluction. You need to know this word. All right, so highlight that whole little piece. This is when in places of tundra regions, we look at ecosystems next year. Okay. When the ground, these are usually semi-frozen, okay, areas, but when the ground begins to thaw out and the ice begins to melt again, like we just said, the soil beneath becomes liquid and can start to move. Okay, so when it gets saturated or overpowered by water, it can start to move. All right. Let me just see how we're doing for time. Okay, next one then, landslide. All right, loosened surfaces of the rock and soil suddenly slide down a steep slope such as a cliff face. So now what we have, okay, suddenly is our speed. These are fast. Landslides are fast. Loosened rock surfaces on a steep slope such as a cliff. Now we've got our gravity and also our angle. All right, remember we said about our angle of slope. A cliff face will be almost perfectly vertical. All right, so you get these landslides. You can also see there's some causes down here: the pull of gravity, lubrication of water. So in the landslides case, you could actually combine all three factors: gravity, water, and angle of slope, depending on the speed, and these are fast. All right, there's two types of landslides: sliding or slumping. All right, little arrow, okay, can come out of here, out of sliding and up to this diagram above. Okay, so this one here shows about the sliding plains, big chunks of the land sliding along the surface. All right, so again, you got your angle, and then you've got the pull of gravity sliding those blocks down here. All right, slumping is on the next page up here. I'll show you that just now. So now we got our slumping, which is just here. The landslide is caused by slumping, where pieces fall down in big chunks on top of each other. We'll look at some diagrams of this in our next lesson on Friday, okay? But for now, that's all we need. Coming through, again, although most landslides have natural causes triggered by human activity, quarrying, which is mining, removal of vegetation, construction of roads, they can all cause landslides. So again, just some examples. You can highlight just Hong Kong. We don't need to know all this about Hong Kong, but that's just your landslide example. All right. Moving on quickly because it's going to run out of time here. The last one is rock falls, and again, speed, fast. Let me move this down a bit. Very fast, gravity and angle this time. There's little water involved in rock falls. Okay. The massive rock falls from a steep slope is called a rock fall after a rock is weakened. So you could have your freeze thaw, your frost shattering activity, but you can see how vertical this slope is here, okay? And then once the rock gets weakened, it'll fall down like so. All right. Good little diagram here as well. You can just put a box around it. You need to know what a retaining wall is. Okay, so simple diagram for landslides. A retaining wall, when we're building homes or roads into a into a slope or a mountainside, we build these thick retaining walls to hold back the soil and the rock and the material. Now when this gets heavier and fills up with water and so on, it can break through the retaining wall and smash everything we've built. Alright, so that's just a little example of what happens for landslides. Rock falls, like I said, was the last one. The broken rock at the bottom is called talus, so maybe just very quickly we'll highlight that as well. Alright, I'll send a second video just now outlining some more content and your assignment.